Hello everyone, myself Ravinder Sid. I will introduce you to our project Intellimarks. Intellimarks is an intelligent machine learning based student performance prediction system designed to support students and educators by providing accurate academic insights. The system predicts a student's final exam score, determines whether the student is likely to pass or fail, and generates personalized study recommendations using Gen AI. By analyzing key academic and personal factors such as study hours, attendance, past scores, internet access, extracurricular involvement, and parental education background, Intellimarks helps learners understand their strengths and weakness in advance. So here I will tell you about this SRS software requirement specifications. So Intellimarks is an AI-driven student performance prediction system designed to bridge the gap between raw academic data and actionable educational insights. Modern education systems generate a significant amount of student-related information, yet much of this data remains underutilized. Intellimarks leverages machine learning algorithms to examine student attributes such as study hours, attendance, past academic records, and socio-environmental parameters. Through these inputs, the system predicts a student's expected final exam performance and classifies them into pass or fail outcomes. In addition to predictive capabilities, Intellimarks generates a generative AI module that produces personalized study recommendations. These suggestions are designed to help students understand their weak areas and take corrective steps proactively. This dual predictive prescriptive nature positions Intellimarks as a valuable digital assistant not only for students but also for educators, institutions, and academic counselors. The system emphasizes accessibility, simplicity, reliability, and accuracy, ensuring it remains useful across diverse educational environments. Here we will see overview. Machine learning has emerged as a powerful analytical tool in educational technology. Predictive models such as random forest regressors and logistic regression classifiers can uncover hidden relationships between student attributes and academic outcomes. By training on historical data sets, these models learn patterns that help forecast future scores with considerable accuracy. Intellimarks follows this approach by using random forest for numerical score prediction and logistic regression for binary classification. The integration of Gen AI based recommendation engine sets Intellimarks apart from traditional prediction systems. Instead of merely forecasting outcomes, the system interprets the student's input and generates context aware study suggestions. This transforms raw predictions into meaningful guidance. The system is built with modularity in mind, allowing easy expansion, dataset updates, and retraining the models. Intellimarks ultimately aims to provide a complete academic support ecosystem driven by data and AI. Now we will see functional overview. The primary functions of Intellimarks include a student prediction module, an administrative management panel, a machine learning engine for score and classification predictions, and a recommendation generator. The student module allows individuals to input their academic and personal characteristics and receive an instant prediction with tailored recommendations. The administrative module enables dataset upload, model training, monitoring, and performance evaluation. These components work together to create an end-to-end intelligent academic prediction system. Now we will see quality attributes. To ensure a smooth user experience, Intellimarks emphasizes the importance of several non-functional properties such as performance, security, usability, and reliability. The system is optimized for rapid prediction responses, ensuring results are returned in less than a second. Security measures include hashed password, JWT-based authentication, and sanitized API endpoints. The user interface prioritizes clarity and accessibility, allowing easy navigation for both students and administrators. Additionally, the backend architecture ensures minimal downtime and consistent reliability with mechanisms for model backup and error handling. Now we will see system architecture. The Intellimarks architecture integrates multiple layers including the front-end, back-end, machine learning services, generative AI module, and storage systems. The front-end serves as an interactive platform where users input their details and view predictions. The backend handles API processing, logic execution, and communication with trained models. The ML service loads and executes the random forest and logistic regression models, while the Gen AI module generates personalized recommendations. The storage layer maintains datasets, model files, logs, and performance reports. Here is a diagram where we can see the Intellimarks system architecture, the front end, back end, ML service, Gen AI module, and storage. That's all. That's it. Thank you.
Hello everyone, myself Karthik Mehnoth and I would be demonstrating our entire code base. So the main two folders inside our project is backend folder and the front end folder. The backend folder is built using Python and sklearn for training the models. So basically the backend folder is further divided into two folders, app and ML. The ML folder consists of our dataset and the models we have used for training. So we have used logistic regression for classification because it turns everything into probabilities, because it uses sigmoid function and also it is easy to interpret. Next we have regression. So for regression we have used random forest. The reason behind using random forest is that it fits many decision trees, so it avoids overfitting. Next we have the app folder, which is used for routing our request. So basically we have three requests: the predict score, which is sending request to the regression model. Then we have predict pass and fail, which runs the classification model, and we have also built the AI suggestions using the Gemini model on Hugging Face. So this is all about the backend folder. Next we have front end. So front end is built using React. So choosing React because it allows modularity by building the entire UI into components. So the main folder here is source folder. It has main file app.jsx, which is the main UI that you see while opening our website. So it is divided into three components: the hero component, prediction section, and the footer. So the hero section is the first thing you see while opening our website, and it is built here. Then we have prediction section. This is the most important section where the user gives an input, and then these inputs are routed using Axios to the backend, and then backend predict it. Next we have suggestions.jsx. In this component we are sending the user inputs to the Hugging Face model so that it can predict and give out AI suggestions. And then we have footer, which is generally used for branding and providing links to important resources. For example, here we have sent it to GitHub, and this is all about important things about our front end. Now I would like to call Ravinder to demonstrate how our project work.
Hello everyone, I would be demonstrating our project Intellimarks, an AI-powered student performance prediction system. The goal of Intellimarks is to predict a student's final exam marks and determine whether the student is likely to pass or fail using machine learning. So here we will start our prediction. Here the user enters details such as study hours per week, like varying from 0 hours to 40 hours. And along with that we have attendance rate here in the classroom varying from 0% to 100%, previous exam scores, internet access at home, and extracurricular activities, and parent education level, whether it is high school, bachelor's, master's, or PhD. So once I fill these values and click predict, the system generates two results. Here on the screen we can see our result. First is the marks, predicted score obtained from out of 100, and the final outcome, whether he or she is pass or fail. This gives a quick and meaningful insight into a student's academic trajectory. The system uses two machine learning models, a random forest regressor to predict the student's final marks, and a logistic regression model to classify whether the student will pass or fail. The models are trained using a publicly available student performance database. And here, using Gemini or Gamma, the system generates AI-powered personalized suggestions. As we can see on the screen, the suggestions are there. The backend is built using Python, sklearn, and frontend using React. To summarize Intellimarks, combines traditional machine learning with modern generative AI. It not only predicts performance but also guides students with personalized suggestions. That's it, that's all. Thank you for watching.
Today, I, Udit, will present complete design of a student performance predictor system using four important types of UML diagrams, which include one use case diagram, eight sequence diagrams, one class diagram, and one component diagram. And in total, there are 11 diagrams that overall represent how a student performance system works. So let me begin with the use case diagram. So here you can see we have two important actors. One is the user and other is the admin. User is the student, whereas admin is the manager of the system. So you can see the admin can train the model, admin can upload the dataset, and admin can download the performance report. Training the model here involves training two type of model. One is a classification model and other is a regression model. Classification model uses logistic regression, whereas regression model uses random forest. Also, now you can see the user. User can ask the model to predict and can view the prediction result and can also, if he or she wants, can generate suggestions for improvement of his or her grade. So now let us go to the new diagram. That is a sequence diagram. I have made a sequence diagram for each of the use case for both the actors. So I would be here explaining important sequence diagram from each actor. So let us consider from the student actor or user actor first sequence diagram, that is of request prediction use case sequence diagram. In the sequence diagram, you can see student would request the front-end browser. Front-end browser would then send the post HTTP request along with the input data. This would be then sent by received by the controller, which would then send this data to the backend. Backend would then load the model, would fetch the result, and as soon as the results are fetched, it would send back it to the front-end browser. This front-end browser would then display the results to the user. Similarly, in a similar way, you can also refer to the other use case sequence diagrams, that is view prediction result use case and solution generator use case. Now let me come to the important use case diagram of the administrator. Use case sequence diagram of the administrator, that is the train model sequence flow. So we have here train two type of model. One is sequence, one is classification model and the regression model. Classification model predict whether the student would pass or fail. Regression model would predict the score here. So let us see one of them because both sequence flows are approximately similar. So for the train classification sequence model, you can see the admin would command the controller to start the training. Controller would then fetch the first of all fetch the dataset from the dataset storage. This dataset storage would be sent to the controller back, and then this dataset file would be sent to the training module. This training module will pre-process the input and prepare it for model to be trained. Then this pre-processed data would be sent to the classification model or regression model, and this model train itself on these dataset. Then this trained model is sent to the training module back, which would then save this model in the model store, and admin would receive the acknowledgement that model is trained and would receive a report which would give you the performance metrics of the model, which you can see in this sequence diagram. So for you can this trained model actually is the job lib file. This is for the logist regression model and this is for the logistic model, whereas these are the source code files for the both the model trainings. So let us now go to the next diagram. So now let us start with a new diagram, that is class diagram. Here you can see we have included all of them, almost all important entities and classes here. So you can see here we have a user class which is inherited by admin and student class. Admin and student class you uses attributes and methods of this user class. Further, this API controller class acts as an entry point to our system, handling all important API requests, such as predicting outcomes, training models, uploading dataset, and generating suggestions. Then comes this prediction service class, which uses two components, um, that is model and dataset. This prediction service class trains the model using the dataset, and then this model, after training, generates a report which can be downloaded by the admin. These datasets consist of many student records, which consist of various attributes such as study hours, attendance, past scores, etc. If required by the user, using this API controller class, user can also generate suggestion using suggestion generator. So now let us come to our last diagram, that is component diagram. In this diagram, you can see web UI in front end communicates with the back end through REST API calls. API server coordinates all the requests, passing prediction tasks to the prediction service, which then load the required model from the storage. API server also interact with the dataset storage and with the report storage to save and retrieve the reports. Thank you. This is all about design documentation of our model.